Telomeres are maybe the most famous concept in all of aging science, the protective caps on your chromosomes that shorten every time a cell divides, like a countdown timer to old age. It's a beautiful, intuitive story, and it won a Nobel Prize. It's also one of the most oversimplified and oversold ideas in the whole field. Let's separate the real science from the supplement marketing. Let's build the real picture first. Your DNA is bundled into structures called chromosomes, and on the end of each chromosome sits a protective cap called a telomere. The classic analogy is the little plastic tip on the end of a shoelace, the aglet, that stops the lace from fraying. Telomeres do the same job for your chromosomes, protecting the important genetic information from damage. Now here's the key mechanical fact. Every single time a cell divides, it has to copy all of its DNA, and the copying machinery has a quirk, it can't quite reach all the way to the very end of the strand. So a tiny bit of telomere is lost with each division. The caps get shorter and shorter over a lifetime of cell divisions. It's a genuine, elegant, real phenomenon, and you can see why it captured everyone's imagination as a countdown clock for aging. So what happens when the countdown runs down? When a cell's telomeres get critically short, the cell recognizes the danger, its genetic information is now at risk, and it stops dividing. Often, it enters exactly the senescent, zombie cell state we covered 2 episodes ago, or it self-destructs. This creates a built-in limit on how many times most of our cells can divide, sometimes called the Hayflick limit. And as our tissues run low on cells that can still divide and replenish, they struggle to repair and renew, a real contributor to aging. But here's a crucial nuance that the hype ignores: this limit is also one of our most important defenses against cancer. A cancer cell's whole trick is dividing endlessly and out of control, and short telomeres are a natural break that stops damaged cells from doing exactly that. Which is why simply lengthening telomeres is not the obvious win it sounds like. This brings us to the trap at the heart of the telomere hype. There is an enzyme called telomerase that can actually rebuild and lengthen telomeres. Our stem cells and reproductive cells use it. So the dream is obvious: just switch telomerase on everywhere, rebuild everyone's caps, and reset the aging clock. Simple, right? Here's the catch, and it's a big one. Cancer cells have already figured out this exact trick. The vast majority of cancers reactivate telomerase precisely so they can divide forever and become immortal. That's a core part of what makes them cancer. So broadly cranking up telomerase throughout the body risks handing damaged, precancerous cells the very tool they need to become tumors. That's not a hypothetical worry, it's a central reason this approach is so tricky. So when you see supplements marketed as telomere activators or telomerase boosters promising to reverse aging, be deeply skeptical. The biology is genuinely not that simple, and longer is not automatically better. This is educational, not medical advice. So let's land this honestly. Telomere shortening is absolutely real, it's one of the 12 hallmarks of aging, and on average, people with shorter telomeres do tend to have worse health. The science is genuine and Nobel-worthy. But telomeres are one thread in a 12-part tapestry, not the single master switch that the supplement industry wants you to believe. Aging is not simply telomeres running out, and you cannot buy your way to youth by lengthening them in a bottle. What's genuinely encouraging is that the boring fundamentals help here too: regular exercise, not smoking, a good diet, and managing chronic stress are all associated with healthier telomere maintenance, no expensive supplement required. Telomeres are a beautiful piece of biology, and a cautionary tale about how easily real science gets twisted into marketing. This is educational, not medical advice.